Okay, in this video, we're going to be looking at electrical power and electrical energy. Now, quick reminder, we've talked about electrical energy and electrical power, that power is equal to the current times the voltage. Okay, and electrical energy, remember, is equal to power times time. So we can make that as the current times the voltage times time. And I think I normally write that, put it as IVT. I normally write this as VIT. Okay, and oops, that should be a T, my fault. And actually, we'll probably talk about the power as being VI, because that's how it is in your reference table as well. So we might as well make those changes now. So power is equal to PVI, or sorry, P equals V times I, and the work done is equal to power times time, okay, and voltage times current times time. And the other thing, if you look at the reference table, they also give you some other ones where it's equal to I squared times R. It's also equal to V squared over R, but we're going to use those probably a little later on. Okay, and then we can also do the same thing here. We can do I squared times R times T, and then V squared times T over R. And we'll use those, but we'll use those a little bit later on. But remember, we're talking about the amount of energy that goes through these appliances, how much electrical energy is being converted or dissipated into some other form. So if we look, we're going to guess right off the bat. We're going to say how much power is associated with a 1.37 amp appliance is equal to 1.37 amps. And we've got a voltage now of 240 volts. And so since we're looking for power, we're just going to use P is equal to V times I. So P is equal to 240 volts times the current of 1.37 amps. And that's going to give us a power of 328.8 watts. If we look down the next one, it gives us the power. So put this in orange. Power is equal to 350 watts. So we know the power. We know the current is equal to 2.2 amps. And we're looking for what voltage? So we're looking for V. So again, same equation. P is equal to V times I. So in this case, we've got 350 watts. And that's going to equal the voltage, is what we're looking for, times 2.2 amps. So we divide that through, and we find out that our voltage is going to be 159.1 volts. All right, for the next one, we're looking for voltage again. So we'll put this in green. So voltage is equal to question mark. And so we know power is equal to 500 watts. And we know we have a current of 2.5 amps. The point there. And so again, we're trying to find voltage. So again, P is equal to V times I. So in this case, we're going to take the power, which is 500 watts. Looking for voltage. Current is 2.5 amps. So we divide those through. We find that our voltage is a whopping 200 volts. Now, this next one talks about something we talked about in the video lesson about how the electric company actually sells you electricity. They don't ever sell you actually electrical charges. What they do is they sell you electrical energy. And so we have a brand new unit, and I'll put this over here, a kilowatt times hour. And so what this is, the kilowatt is a unit of power, the hour is a unit of time, and as we said way up here, P times T, that is electrical energy. That is equal to W. Now, normally our unit for electrical energy is joule, okay? But because we get so much energy from electricity, they rewrite this. In fact, if you make out 1 kilowatt hour and you turn that into joules, that is going to be equal to, and I'll put this in a different spot here. Remember, there are 1,000, I don't want green, hang on, I want blue. There we go. There are 1,000 watts in a kilowatt, and then there are 3,600 seconds in an hour. I got that by doing 60 minutes times 60 seconds, so to get 3,600. So that's times. So there's actually 3.6 times 10 to the 6 joules in 1 kilowatt hour. Okay, so if you take a look here, it says the electric company charges 8 cents per kilowatt hour. So I've got this question, so money is 0.8 cents per kilowatt hour. And so this is cost per energy, if you will. Okay, and it says at 2 kilowatts, so we know power is equal to 2 kilowatts, and time is equal to 3 hours. Now, in every other instance, I've told you, we live in an MKS world. You got to kick everything into meters, kilograms, and seconds. In this case, which should be watts, it should be seconds, it should be against joules. But this, to make our lives easier, we're going to leave it in kilowatts. In order to find that out, in order to find your energy in kilowatts, in kilowatt time and kilowatt hours, what you're going to do is you're going to take the number of kilowatts, so our power, I'll put this in blue pencil, power, and you're going to multiply that by your number of hours. Okay. And so that'll be times, and I'll put this in blue pencil, times time. And so that still is giving us electrical energy. So to find the amount of energy in kilowatt hours, you literally take the number of kilowatts. So in this case, 2 kilowatts times 3 hours. So my W is equal to 2 kilowatts times 3 hours will give us 6 kilowatt hours. Okay. So a kilowatt appliance is pretty big. It's 2,000 watts. That's huge. But you can see it's 6 kilowatt hours is the amount of energy that we use. Now, if we know it's going to cost us, and I'll highlight this, 8 cents for every kilowatt hour, and we know that we have 6 kilowatt hours, to find the amount of money, you literally just put in, okay, you're going to do, 8 cents per kilowatt hour, and then we're going to multiply that by the number of kilowatt hours. And so what I would do here, I would say, oh, okay, I'm going to go 0.08 times 6. And so it's going to end up costing me 48 cents in order to run that thing. So 2,000 watts, that's a lot. And it only costs us less than 50 cents to run that for those 3 hours. So electrical energy, it's a really cheap way to get us the energy that we need. And that's the reason why it's the foundation for our entire modern society, as you heard me say, okay, in the thing. So now we look at the next one. We've got a 1,500 watt appliance. So our power is equal to 1,500 watts and a time of equal to 3 hours. And how much electrical energy? So W. Now, without it being said, I'm automatically going back to my MKS world, so I need to change my 3 hours into seconds. So what I'm going to do is I'm going to multiply the fact that there are 3,600 seconds in every 1 hour. And so I'm going to find out that that is, I think, 10,800, but let me just double check that to make sure. So 3 times 3,600, yeah, 10,800. So that's 10,800 seconds. And so if I were to find out how much electrical energy, W is equal to P times T. So I could make that 1,500 watts times the 10,800 seconds. And so that's going to give me 1.62 times 10 to the 7th joules when I do that. Now, that's the old school. That's our normal way. But we also have that new way of finding out the electrical energy. So if we want the energy done in kilowatt hours, so I'll put this in here, kilowatt hours, I'm just going to have to find the number of kilowatts. Well, 1,500 watts, in order to change it to kilowatts, I'm going to divide by 1,000, so 1.5 kilowatts. So I would go 1.5 kilowatts times the number of hours, which in this case is 3 hours. So that's going to give me 4.5 kilowatt hours. Both of them are acceptable. Okay. The reason why I did this second one, I'll highlight this. The reason why I did the second one is because I peeked and I saw the next question. What's the cost of running the appliance above if the electric company charges you 15 cents per kilowatt hour? So for that, I want my electrical energy in kilowatts. And so I've got that it's going to cost me 15 cents, 0.15 per kilowatt hour. And I know I've got 4.5 kilowatt hours. So to find the amount of money, I just take my 15 cents per kilowatt hour, and I'm going to multiply that by 4.5 kilowatt hours. That was my total energy. And so that's going to give me a whopping 67.5 cents, or $0.675. So, which of course, the electric company is going to round up to 68, definitely. So that's how we find those. So this is kind of a nice to know. These last three are actually something really good to know, as eventually you'll get out and start paying for your own electrical bills and stuff like that. So you can see how much energy you are using inside your house. Okay, if you get the opportunity, go take a look. Ask your parents for the electrical bill. Take a look at how much electrical energy you used and how actually little that it actually costs compared to the amount of energy. Because if you think back to when we did the power lab, how much energy you expended on the order of 2,000, 3,000 joules running up those stairs, think about how tough that was, and then look at how little it would cost to do that by electrical. So, hope this helps. Everybody have a great night. We'll see you later. Bye.